Hello, my name is Ben Orr, and I will be demonstrating how to solve this integral sine of x squared plus y squared dx dy. We're going to be integrating in x from 0 to the square root of 4 minus y squared, and integrating in y from 0 to 2. First things first, let's figure out where this region is. If we put x equal to its upper bound, square root of 4 minus y squared, and solve x squared equals 4 minus y squared. And if we move y over to this side, x squared plus y squared equals 4. This is the equation of a circle with a radius of 2, because if we take the square root of all of this, 4 is going to turn into 2. So what we found is that this area that we're integrating is somewhere in this circle with a radius of 2. And then when we look at our y bounds, it shows that y is a positive value. So that means that it has to be either of these two quadrants that we're integrating in. And because x is equal to only positive values, that means that this is the region that we are integrating over. Let's convert this to polar coordinates to make the problem easier to solve. We're going to treat the x bounds as r bounds and y bounds as theta bounds. So when we look here, we're going to see that y is equal to pi over 2, or theta is equal to pi over 2, and r is obviously equal to 2 wherever we go, and its lowest value is 0. So if we rewrite this, it's going to be, in terms of r, 0 to 2, in terms of theta, 0 to pi over 2, and then we're going to have sine of x squared plus y squared r dr d theta. So dx dy is equal to r dr d theta, and we're going to change this x squared plus y squared into the polar form. So x equals r cosine theta, and y equals r sine theta. So if we change this around, we're going to be integrating from 0 to 2, and from 0 to pi over 2, that's sine of r squared cosine squared theta plus r squared sine squared theta. When we factor this, r dr d theta. When we factor this out, or factor out an r squared, it's going to be sine of r squared times cosine squared theta plus sine squared theta r dr d theta, which is equal to the integral from 0 to 2, 0 to pi over 2 of sine of r squared, and using our trig identities, this is equal to 1, r dr d theta. So our final integral put into polar coordinates is integral from 0 to 2, 0 to pi over 2 sine of r squared r dr d theta. Right, in order to integrate this, let's use u substitution to make it easier. So we're going to let u be equal to r squared. We're going to let du be equal to 2r dr. And we can move this around a little bit and flip-flop the sides so that du over 2 equals r dr. So this will be equal to du over 2, and this will be equal to u. And so when we rewrite this, it's going to look like sine u du over 2 d theta. Now we just have to solve the integral. So this is equal to 0 over pi 2 in parentheses negative 1/2 cosine u, and this is going to be evaluated from 2, 0 d theta. This equals negative 1/2. We're just going to move this 1/2 in front of this. Negative 1/2, 0, 2. And then when we evaluate from 2 and from 0, we're going to get cosine of 4 minus cosine of 0 d theta, which is equal to 1/2 0 to pi over 2 cosine of 4 minus 1 d theta. Okay, so now we're going to integrate over these bounds. So this is equal to negative 1/2 cosine 4, and when we integrate with respect to theta, there's no, this is just a constant, and so theta would have disappeared in the derivative, and so we're just going to put theta here, and then minus theta. We're going to evaluate that from theta equals pi over 2, theta equals 0. This is equal to negative 1/2 cosine 4 pi over 2 minus pi over 2. If we evaluate at 0, it just cancels it out, so we just are left with evaluating at pi over 2. This is equal to negative cosine of 4 times pi over 4 plus pi over 4, because we factored in the negative 1/2, so it flipped the signs here. And then this, if we just move this 4 under, it's negative cosine 4 times pi all over 4 plus pi over 4. This is equal to, if we factor out a pi over 4, pi over 4 times 1 minus cosine of 4. And this, right here, when we put it into a calculator, is roughly equal to 1.299.